Hey guys, today we're doing the Doppler effect. This is my second video in the series, second and last video in the series. If you haven't already watched the first video, I recommend that you go and watch that now. It's only 10 minutes long and it's all the theory you could possibly need on the Doppler effect, and it will help you understand this video. I've extracted the hardest questions that I've come across in past papers for the Doppler effect, so everything that you encounter after this should be quite easy if you can do these. Okay, so let's get straight into it. I did write it out so it would be clearer. How do I remove all, just forget that writing there. Okay, so it says the alarm of a vehicle parked next to a straight horizontal road goes off, emitting a sound with a wavelength of 0.34 meters. A patrol car is moving at a constant speed on the same road. The driver of the patrol car hears a sound with a frequency of 50 hertz lower than the sound emitted by the alarm. Take the speed of sound in air as 340 meters per second. Even if they don't specify, just remember that the speed of sound in air will always be 340. Okay, so let's read again, but with making notes. So it says the alarm of a vehicle parked next to a straight horizontal road goes off. So the first thing you need to understand there, if the alarm is going off, this is going to be the sound source. So this is the source, not the listener, because it's going off, it's emitting a sound. We're going to have the frequency of the sound source here. The next thing is the fact that it's parked. If it's parked, it means that it's stationary. It's not moving, which means that its velocity will be 0. So let's just write that down. We've established that this vehicle is the sound source. So our velocity of the sound source is going to be 0 because it's parked, and our frequency of the sound source we do not know, but they did say that the wavelength is 0.34 meters. Now I did mention the formulas for wavelength in my previous video, please go and check that out, but it's one of two. So you can either say velocity over your over your frequency is equal to your wavelength, because wavelength is equal to, what was it, velocity times your period, and period is 1 over frequency. Yeah, that's right. Okay, so your wavelength is either equal to velocity times your period, or it's your velocity divided by your frequency, which makes sense because your period and your frequency are indirectly proportional. And in this question, they have not mentioned anything about the time. So we know that we can't use this formula. We can't use period. We have to use the first formula, which is velocity divided by frequency. Now, what some of you may be tempted to do is say velocity over frequency is equal to wavelength. So my velocity of the sound source is 0 divided by frequency is equal to my wavelength. My wavelength is 0.34. Therefore, frequency is equal to 0. This is wrong. And I'll tell you why it's wrong. Firstly, you can't have a frequency of 0. Like, even if you didn't understand why, just by knowing that you cannot have a frequency of 0, you should be able to tell that something's wrong. Yeah, so you should be able to tell that something's wrong immediately if the frequency is giving you 0. Now, we're also working out the frequency being emitted by the source. So we can't use the velocity of the source because it's not related. You're going to use the speed of sound in air, because the frequency of the sound being emitted by the source is traveling through the air. The actual source is not moving, so it wouldn't make sense to compare those two. The actual sound is traveling through air, so it would be important to understand the velocity of the medium it's traveling through, and that is why you're going to use the speed of sound in air. So you're going to say 340 over your frequency of the source will give you wavelength, which is 0.34. But even if you don't understand that, just remember you should never be getting 0 as your frequency. And the only frequency that they gave you in the question was the 340. You can't say 50 hertz lower, because that's not the actual frequency. It's x minus 50, but we'll get to that. But anyway, that should give you, I'm just working out the answer, 340 divided by 0.34 should give you a frequency of 1000 hertz. So this is your frequency of the sound source, right? Then, oh, and they also asked, I forgot to mention, they also asked to state the Doppler effect in words. And that you take straight from your exam guideline, and it is the change in frequency of the sound detected by a listener because the sound source and listener have different velocities relative to a medium of sound propagation. The next thing they asked was, is the patrol car driving towards or away from the parked vehicle? Give a reason for your answer. So it's going to be away because it says that the driver of the patrol car hears. The word hears tells you that the driver of the patrol car is the listener. And it says that they hear a sound with a frequency 50 hertz lower than the sound emitted by the alarm. So if it's lower than the actual frequency, then they're moving away. Because if they heard a sound with a frequency higher than the frequency of the sound source, they would be moving towards. But they even put lower than in bold. So that's how you know, like, it's definitely moving away from. Okay. Then they say calculate the frequency of the sound emitted by the alarm. And remember, I calculated that, and that was 1000 hertz. Oh, you may have been a bit confused where I got that first question from, the one about the frequency of the sound emitted by the alarm. That was the frequency of the sound source. And I told you that you have to use the speed of sound in air, and you have to use your wavelength. Then the next question that they ask us is, the patrol car moves a distance of X meters in 10 seconds. Calculate the distance X. So before we can actually start calculating anything, we need to establish what we have and what we don't have. I actually should have done this in the beginning. But nevertheless, let's do it now. Whenever you get Doppler effect questions, jot down what you have first. It prevents you from making mistakes. So obviously now we've worked out that Fs is equal to 1000 hertz, but before we would have just put it as X, right? Because we didn't have it. And we worked out that the velocity of the sound source is 0. We worked out that the velocity of the listener, we actually don't know this. Yeah, no, we don't know this. And then what else did we work out? We worked out that the frequency of the listener is 50 hertz lower than the frequency of sound. So it's just going to be 1000 minus 50. And then we have our V, which is 340 meters per second. Now let's look at the question. The patrol car moves a distance of X meters in 10 seconds. Calculate the distance X. Okay. So if we're working with distance and we're working with time, what formula are you thinking of? Well, firstly, you know that when we work with distance in Doppler effect, we're talking about wavelength. When we work with time, or we work with seconds in Doppler effect, we're always talking about the period. So they gave us the wavelength and they gave us the period, which means we're going to use this formula. Now, this is the velocity of the listener, because they say the patrol car moves. And remember, the driver of the patrol car is hearing the sound. So we actually want the velocity of the listener. It's different to the other one we calculated, where we were worrying about the velocity of the sound in air, because the actual frequency of sound, or the sound, was traveling through the air. Now, the patrol car is moving a certain distance. So we're worrying about the wavelength with regards to the patrol car, which means we're going to use the velocity of the patrol car. So whenever you get stuck, just kind of try and understand the relationship between things. Then you will know which velocities you have to work with. And even if you didn't understand it in that way, oh, I'm working with the wavelength of the patrol car, so I have to work out the velocity of the patrol car. Even if you didn't understand that, just remember that the only missing thing here is the velocity of the listener. So why would you calculate something you already have? That should also be a given, that this is what you should be working towards. So we want to work out the velocity of the listener so that we can plug that answer into this formula over here and work out the wavelength, which is our distance. Let's first do that, the first part of the equation, or the first equation, which is this equation. It's FL is equal to V plus minus VL over V plus minus VS times Fs. So let's just write that. It is FL is equal to V plus minus VL over V plus minus VS times FS. All right, that's correct. Now, how you determine whether the numerator or denominator is going to be positive or negative, I already discussed this in my first video, but just to recap, if your listener is moving away, you would have the top part as being a negative and the bottom part as being a positive. If your listener was moving towards the sound source, you'll have your V plus VL, and the denominator would be V minus VS. Okay, so because it's moving away, it's going to be V minus VL. Let's do that. Your frequency of the listener, we got that as being 1,000 minus 50, which is 950. So just going to write there 950 is equal to 340 minus velocity of listener, we don't know, over 340 plus the velocity of the sound source, which we worked out to be 0. Oh, by the way, 1 always has to be 0. I'm so silly. 1 always has to be 0. If the velocity of the listener is not 0, then the velocity of the sound source is 0. If the velocity of the sound source is 0, then the other one cannot be 0. One of them will always be 0. So I actually didn't need to check that. But anyway, then the frequency of the sound source is, I think that was 1,000. Yeah, it's 1,000. Okay, so divide both sides by 1,000. 950 divided by 1,000 is 19 over 20. Then we're going to cross multiply, is equal to 340 minus VL. Yeah, because you times by 340 on both sides. Okay, times 340 is 323. Is it? Yeah, it's 323. Minus 340 is equal to minus VL. So that minus 340 is minus 17 is equal to minus VL. Therefore, the velocity of the listener is 17 meters per second. I just want to make sure that that answer is actually correct. Yeah, it's correct. Okay. Let us do the next equation, because you're not done yet. You only worked out the velocity of the listener. They want to know the distance x. So you're now going to plug this into the first equation. Let us make some space. Okay. So now we're going to have wavelength is equal to 17 times 10. And that should give you wavelength is 170 meters. Therefore, x is 170 meters. Please don't forget to change your wavelength to x, because then you just randomly calculated wavelength. And I know it should be a given that wavelength is the distance, but sometimes memos are faulty. So just remember that you do actually use the stuff that they give you. They ask for distance x, so you must give them the value of x. Don't just leave it as wavelength. Okay, next question. This one is a little bit more difficult because we will be using simultaneous equations. And this is one of the hardest questions or type of questions that can come up with the Doppler effect. So I wonder if this is clear or not. Okay. It says a police car moving at a constant velocity with its siren on passes a stationary listener. The graph below shows the changes in the frequency of the sound of the siren detected by the listener. So first things first, a police car moving at constant velocity with its siren on passes a stationary listener. So we know that the velocity of the listener is going to be 0. Then they talk about how the graph shows the changes in frequency of sound of the siren. Now the siren is emitting the sound. So that is going to be our sound source, which means that this graph is giving us Fs. This whole graph is showing us Fs. Okay. Then obviously your V will be, as usual, 340 meters per second. Do we have the velocity of the sound source? No, we don't. We don't have the velocity of the sound source. Do we have the frequency of the listener? Siren detected. Sorry, I made a mistake. It says here, frequency of the sound of the siren detected by the listener. So that is actually the frequency of the listener. Sorry, my bad. Which means we don't have FS. And yeah, V is just 340. Okay. So the first question they ask is state the Doppler effect in words. You can expect this question to come out for every Doppler effect question, as I said. So just remember to learn this definition. And it is just the change in frequency of the sound detected by a listener because the sound source and listener have different velocities relative to a medium of sound propagation. Cool, easy 2 marks. Then they say write down my. Okay. They say write down the frequency of the sound detected by the listener as the police car approaches the listener. So remember that when the police car approaches the listener is getting closer to the police car, even though the listener is moving, but still, because if your friend comes towards you, you are technically getting closer to your friend, right? So the listener is getting closer and closer to the sound source, which means we'd expect a bigger frequency. So here we're going to expect a bigger frequency. And then when it moves away from the listener, when the police car moves away from the listener is not moving away from the sound source, but the distance between them is increasing. So technically the listener is also moving away from the sound source. So we'd expect the observed frequency to be smaller. So we're going to expect a smaller frequency here. Okay, so 6.3, calculate the speed of the police car. The police car is the source that is emitting the sound. It's a sound source. So we actually want Vs. But we can't just, obviously have to use the big formula because you can see it's 6 marks. But you can't use it just yet because we have 2 unknowns. We have Vs missing and Fs missing. But we do have 2 different FLs. And whenever we have 2 missing unknowns, we know we have to do simultaneous equations. So we need to set up 2 equations, and we also happen to have 2 different FLs. One for approaching, when the police car approaches the listener, and one for when the police car moves away from the listener. And whenever you're unsure, always look at what was asked in the previous question, the question just above the question that you're stuck on. The previous question usually gives you a hint about how you need to go about doing the next question. So in 6.2, they asked us for the frequency for when the police car approaches and when it moves away. So we know we need to set up 2 equations, and we have 2 different FLs. They gave us that hint. So that is what our 2 equations are going to revolve around. We're going to set up an equation for towards, and we're going to set up an equation for away. So let's just quickly write down the formula. FL is equal to V plus minus VL over V plus minus VS, all multiplied by Fs. And then we're going to have FL is equal to V plus minus VL over V plus minus VS, all multiplied by Fs. Did I do that correctly? Yeah. Okay. So in the towards equation, we have to use the bigger frequency because when you move closer to something, the frequency, the observed frequency is greater. So we're going to use 170. Then it's just 340 plus. You're going to use a positive in the numerator because we're moving towards. VL is 0. Then that is divided by 340 minus VS, which we don't have, and then multiplied by FS. Here we are moving away, so we need to use the smaller frequency, and it is 340 minus 0 because when you move away, you use the minus in the numerator and a positive in the denominator. 340 plus Vs, all multiplied by Fs. So we need to make the equations in terms of a common unknown. So in terms of something that's unknown in both of them. Now we can either make Vs subject of the formula or Fs subject of the formula, but you can clearly see that making Vs subject of the formula is going to be extremely messy because it's being subtracted and added from something, and also it's part of a fraction. So that's like super dangerous and risky. Rather just make Fs subject of the formula, because all we need to do is divide the respective FLs by everything in brackets. So it's pretty easy to make Fs subject of the formula. Let's just go ahead and do that. I hope my phone isn't about to die. Oh, okay. So Fs is equal to 170. We're dividing by everything in brackets, so we're going to multiply by the inverse times 340 minus Vs all over 340. Then over here, Fs is equal to 130 divided by everything in brackets, so we're going to multiply by the inverse 340 plus Vs all over 340. I'm going to name this equation 1. Sorry, it's so messy. I barely have space. And I'm going to name this equation 2. Then you're going to say equation 1 is equal to equation 2, because both of them are equal to Fs, so that's why I can equate them. Now, both of them are being divided by 340. The denominator is 340 in both of them. So you would multiply by 340 on both sides to get rid of it. I'm just not going to show that step because I don't have space, but please show that step in your exam. So now I'm going to have 170 times 340 minus 170 Vs being equal to 130 times by 340 plus 130 Vs. Now I'm going to take the 130 Vs to the left-hand side. So 170 minus 130 is minus 300. So I have minus 300 Vs. And I'm going to take the 170 times by 340 to the right-hand side. So I have 130 times 340 minus 170 times 340. Which will give me, I'm just going to calculate that, 130 times 340 minus 170 times 340 gives me minus 1,000, minus 13,600. 13,600. And that is equal to 300 Vs. Divide by 300 on both sides. I'm just making some space. Whew. Okay, so if you divide by minus 300 on both sides, you should get Vs being equal to 45,33 meters per second. Let's check that my answer is correct. Yeah, it's correct. And those are examples of the hardest questions you can come across in the Doppler effect. It cannot get harder than this. And if you can do this, you should be able to do all of the other questions. Good luck.